Alright, so we're going to do part 2 now of this methods for simplifying radicals. We're going to do the bottom part where it says recognizing perfect squares and cubes and so on. And that honestly is where this is going to come in, the chart that I put on the front of these notes. If you recognize what these perfect squares are and these perfect cubes, honestly, I don't expect you to recognize all of these to the 4th and the 5th and the 6th root because those just aren't going to be that familiar to you. But these will help you a lot. And there are a few of these that you may know on the 4th power and the 5th power. And so these first 2 columns will help you a lot. So I'm going to try to make the directions brief if I can. I have just 3 steps. The first one is just what I just talked about. You need to know, be able to know or recognize when there's a perfect square that is a factor of your number. And if you don't remember what the word factor means, when you write things as factors, it's things that you're multiplying. And so if you can recognize those perfect squares, cubes, whatever they are, as factors, it'll help you, it'll be faster, I think, than doing this other method where you have to do the prime factorization. But everybody's different, and so that's why I'm showing you both. I want you to be able to do the thing that's easiest for you so that this is less stressful for you. So if you can recognize those things, then rewrite the radicand, that's the thing under the radical, in factored form using those perfect squares and cubes or whatever they are. Okay, and then the last one is pretty simple. You're just going to take the square roots of the things, or the square, or the cube root, or whatever it is, of the things that you just identified. So you will take the square root, cube root, whatever the index is, that's the root that you're taking. I'll just do that. And if there's anything left, that stays in the radical. That stays under the radical. That'll be your radicand when you're finished. So if those other factors can't be simplified, they're going to stay there under the radical. If everything can be simplified, then just like before, the radical goes away. Okay, so I'm going to do a couple. I want to show you on one of the examples that I had there. I'm sorry, I paused. I was looking to see what I had. I'm going to reuse this example to start with. If I've got the square root of 24 into the 5th, then I know that if there's not an index, I know that it's understood to be 2. So I'm looking for perfect squares. So as far as the number goes, I know that 4 is a factor in 24. It's 4 times 6, and 4 is a perfect square. That's why I went to that one. And then as far as your variables go, here's the easiest thing that I know to do. Break them up in groups of whatever your index is. So I have, sorry, I almost read an X. So I have an n squared, and an n squared, and an n to the first, because 2 and 2 and 1 is going to give me 5. Remember, we just did properties where if you multiply like bases, you add the exponents, and that's an understood 1. So there's my n to the 5th, and I just broke it down. So here's what I have. The square root of 4 is 2. The square root of n squared is n. The square root of n squared is n. And that leaves me with these two things still under the radical. So my final answer is 2n squared on the square root of 6n. Another way you can look at that, if you really get this and it makes sense to you, is, and we'll try to say it as simple as I can, you find the biggest number that 2 will go into in 5, like 2 goes into 4, and the square root of n to the 4th, I can change that. The square root of n to the 4th is n squared, because you're taking half. When you, if it's a square root, you're taking half. If it's a cube root, you're going to take out groups of 3. And so, for some of you, that's going to click, and you're going to be like, oh, I get what she's saying. And some of you are sitting there thinking, I don't have a clue what she's saying. So if you don't, then whatever your index is, if you're one of those people that you're not really sure, whatever your index is, rewrite that variable in groups of that index, n squared, and then there's one left over to give me the n to the 5th. Okay, so just a quick one, just so you can see the comparison to doing it this way and doing it this way where you do the prime factorization. All right, let's do a couple more. If I have the cube root of 24x to the 7th, if you will learn those perfect squares, perfect cubes, I know my brain is immediately saying, hey, 24 has a perfect cube in it. It has 8. 24 is 8 times 3, and 8 is a perfect cube. X to the 7, if I'm going for cube roots, then I want to break that down to x cubed, and x. I'm going to break it down into groups of 3. Or you can break it down to x to the 6 and x. And then you would take half of that. So that's going to give me the cube root of 8 is 2. Sorry, I didn't put my 3. The cube root of x cubed is x, and the cube root of x cubed is x, and that leaves me with the cube root of 3x. So my answer is 2x squared times the cube root of 3x. I'm going to do my little side note over here on this part. I could have taken that x to the 7th and broke it down to x to the 6th times x to the 1st. And when I take the cube root of x to the 6th, you're taking half. So what I would do would be 6 divided by 3, and it would give me 2. I'm going to do one more. I've got the cube root of a negative 625, a to the 6th, b to the 6th, c to the 5th. So here's where those cube roots may or may not, you may recognize them, you may not. If you don't, then you've got that prime factorization that you can fall back on, and you can break it down, and then you're going to group it into groups of 3 because that's my index. But I recognize that I have 125 as a perfect cube in that. So here's what I'm going to do. The other thing that I wanted to point out on this one is it's got a negative. If the index is odd, 3, 5, 7, 9, and so on, if the index is odd and this number is negative, then you're going to work it where that negative is going to come out. So I'm going to rewrite this negative 625 as negative 125 times positive 5. And then that a to the 6th, if you want to break that down to groups of 3, I've got an a cubed and an a cubed, a b cubed and a b cubed, a c cubed and a c squared. So here's where it's not tricky, it's just something you have to remember. If the radicand is negative and the index is odd, then when I take the cube root of negative 125, I'm going to get a negative answer. And that's going to be negative 5, because if you think about it, negative 5 times negative 5 times negative 5, you can't see that. I apologize. Let me scoot up. If I take the cube root of negative 125, that's negative 5 times negative 5 times negative 5, and that's going to give me the negative 125. So my cube root here is negative 5. The cube root of a cubed is a. The cube root of a cubed is a. And if you haven't figured it out yet, that means I got two groups of A's. I got the cube root of B cubed and the cube root of B cubed, so that gives me two groups of B's. I have the cube root of C cubed, which is just one group of 3, and that's going to leave me with the positive 5 and the C squared. And I got to put my 3. So I know you're probably thinking, what? But I'm going to say this to you. Back up and watch it again. And maybe again if you need to. Don't make it complicated. And if this method is confusing to you, and you understand doing that prime factorization, even if it takes you longer, the point is that you understand the process and you know how to get the result. So, you're going to have some work with each of these videos. And so whatever you are still struggling with, don't panic. I will be back on Wednesday and we will start working on some things. But this should all be, for the most part, review. This part, because you're taking something bigger than a square root, might be new for you. But even still, if you need to, go back and do the prime factorization method if that is a little bit easier for you, because you are breaking it down into simpler, more basic steps. Okay? All right. See you Wednesday.